What word on this page looks familiar to you? Pythagorean theorem. Okay, good. What is the Pythagorean theorem? A squared plus B squared equals C squared. We used this a lot last semester. Okay. What you're going to see now is that we have square roots involved. Okay, that's going to be the biggest part of this chapter is square roots. Okay. With the Pythagorean theorem, does it matter what numbers you put where? It does matter, right? How? What is our A and our B? Remember, Pythagorean theorem is always with a right triangle. Okay, but what's the A and the B in this one?
2 squared, 3 squared.
Right. So remember, we always circled those because those are connected to my right angle. Okay, so we always wrote those as our A and our B. Square root of 2 squared plus square root of 3 squared. And then which one was always C? Across from the hypotenuse, or we always underline that one. Okay, we had circled the 2 legs, and then we underlined our hypotenuse. Hypotenuse is always across from our right angle. So then we have C squared. Okay, so filling it out is no different. Okay, that part is the same. But now when we solve, what happens if you have a square root and a square together? They cancel out, right? They're opposites of each other. So that square and square root cancel out. So you're only left with what's on the inside?
2 plus 3
2.
plus 5.
So with the square root of 3 squared, what's left? What's left if I cancel those out? The 3. And then I have that C squared.
That's 5.
Now we just evaluate. 2 plus 3?
5.
5. Last most important step is to do what to get C by itself? Sometimes we forget. Take the square root. If I square root both sides, I end up getting C equals the square root of 5. And then we're just going to leave it as the square root of 5. Because, is there such thing as a square root of 5? Is there a perfect number that goes into the 5? No. Okay? So, you've seen it before, but what you haven't seen is that squared and square root that cancel out. Okay, but everything else with that is the exact same as it used to be. Okay? Questions with the Pythagorean theorem before we move on? Okay, this whole we're going to be working with radicals. What I mean by radicals is the square root. Okay? Square root means radical. So, we're going to be working on simplifying these all week. Okay, because this is the basis of what this chapter is about. Okay? So, when we multiply radicals, looking at A, what would we do if we just had a normal 3 times 7?
21.
We would just get 21, right? What's different between this and this?
Square.
They have a square root, right? That's the only difference. We're going to multiply our numbers, and we're just going to get one big radical. So, we started with 2 radicals. Now we're all together in one big radical, multiplying them together. Okay? So if I look at B, if I have square root of 2 times square root of 8, what is that?
16 squared.
Not 16 squared.
Square root.
Square root of 16. Now, what's special about the square root of 16?
I assume it comes out whole.
What is it? Square root of 16 is 4. Okay. Any questions about multiplying them together?
No.
Okay, it's the same thing as regular multiplying, except now you just have a radical on top. Okay? Now let's get to simplifying. Okay? First question you ask yourself when you're simplifying radicals. Ask yourself if this is one of the perfect squares. And what did we say it was? It was no, it's not one of them. Okay? Step 2, you ask yourself which of my perfect squares that we listed here, which one can go into 12? Start at 1. 1 goes into all of them, right?
Yeah.
What about 4? Does 4 go into 12?
Yeah, 3 times.
Yes. I'm going to keep going because I want the biggest one. Does 9 go into 12?
1?
Evenly.
No.
No? 16?
No.
Now we're getting too big, right? So I'm going to pick 4. So my perfect square is 4. Now I need what's left over.
3.
12 divided by 4 is 3. Now, the reason I got a perfect square is because we can simplify that. What's the square root of 4?
22.
Square root of 4 is 2. And then can I do anything with the square root of 3? No. So I'm just going to tag it on to the end. That's my answer. 2 square root of 3. Okay? So when you're breaking them apart, you're finding a perfect square. And then you get what that perfect square is. And then you have your leftovers attached at the end.
Neat.
Okay? Let's look at B. Square root of 45. What was that first step I told you to ask yourself?
Is it on the list?
Is it on the list? Is it a perfect square?
No.
No. What's step 2?
What adds up to it?
Figure out which one goes into it. Which one?
9.
It is 9. Does everyone agree with 9? Okay? So 9 is my perfect square. Now I need to find the leftovers, or what is left.
5.
Everyone agree? So to get that, 45 divided by 9. So we get 5. Last step, solve, right? What's the square root of 9? 3. And then tag on what's left over. Let's look at number 1 together one more time. Okay? What is the first question I ask myself? Is it on the list? Is it a perfect square? No. What's the next question?
What adds up?
Find which one goes into it.
9.
Does everyone agree with 9? I heard it from a few of you. So we have square root of 9. What do we need with that?
3.
Yep, we need what's left over, so we have square root of 3. What's the last step?
Solve.
Solve. Square root of 9?
3.
3. Square root of 3. Remember, you're always going to have a perfect square, and then what's left over. Okay? Let's look at number 4 together. Is that in our list?
No.
No. So what do we do next? Go through the list. Okay? I want you to go through the list. See if you can find one. What's happening? What?
Nothing goes into it.
Nothing goes into it. So if nothing goes into it, can we simplify? No. So your answer is just square root of 97. That can happen. Okay? Sometimes there's nothing that goes into it, so we just leave it as it is. Okay? All right. I want you to go try 2 and 3. Okay. Number 2, what's the first thing you ask? Is it on the list? Is it a perfect square?
No.
No. What's the next thing you look for?
What goes into it?
What goes into it? Which one of our list goes into it? What do we come up with? None of them? Does everyone agree with none? Okay, so what's our answer?
Square root of 4.
Square root of 46. Okay? And is it okay that that happens? Yes. Okay? Number 3, what's the first thing we ask? Is it on the list? Square root of 8? Right. It's not on the list, so then we go to our next step. Look what goes into it. Joe, what'd you say? 4. So square root of 4, and then what's left over?
Times square root of 2.
Square root of 2. Why do they have to stay in square roots?
Because that's the equation.
Because it started in a square root. Okay?
It hasn't been taken out.
Last step is what?
Solve.
Solve.
2 square root of 2.
Yep. Square root of 4 is 2. And then I keep my square root of 2. So remember, you always have a perfect square. Simplify that perfect square in your final answer. And then you keep what's left over. Okay? Questions so far? There's one more thing I want to talk about. And that's number 8. What is different about number 8? There's a 5 in front of it. Okay? What is technically in front of the other square root of 3? A 1. Okay? Ideas. How can we simplify this? How can we multiply these together? Exactly right. Yep. We're going to take our whole numbers, multiply them together to get a new whole number. So 5 times 1 is 5. What are we going to do with the radicals? Multiply them together. 2 radicals to form a new radical. What's my new radical?
9.
Square root of 9, right? Does everyone understand that? I started with 2 whole numbers. I ended up with 1. I started with 2 radicals. I ended up with 1. Okay? Now last step is simplify. Can I simplify my radical? What's the first thing you ask? Is it on the list? Yes or no? Yes. Okay, so I have 5. What's the square root of 9? 3. What's my answer? What? 15. 5 times 3 to get us 15. Good. Questions? Okay. Go to that last slide. I want you to try all 4.